Hello, in this video I will do some weight-based dosage calculation problem. So we are learning pediatrics and we'll be calculating dosage based on body weight. Okay, let's start with example one. So here we have an order is for amoxicillin PO 30 mg kilograms per day. So it wasn't originally like that. It was like this. Here, I'll show you. It was all slanted, but you need to know how to rewrite it. It was originally 30 mg per kilogram and then slash day, right? So you need to know how to rewrite it as this as horizontal because this looks really confusing. Um, so I rewrote it like this. It was originally like this, right? They're not going to make it look horizontal and neat like this. You need to know how. And so now we're dealing with complex fractions. So order is for mxln PO 30 mg per kilogram per day administered in equally divided doses every 8 hours. Patient weighs 56 pounds of m 56 pound patient weighs 56 pounds. Amoxicillin on hand is supplied as 125 milligrams per 5 milliliters oral suspension. Round all answers to the nearest tenths. So what are we supposed to do? What is our final answer? What is our final answer? It has to be. Our final answer will have to be mg per day. That's how you know your correct answer. So, oh, sorry. Okay. Sorry. The first part says how many mg will the PT receive per day? Okay. So if you want me to read the problem again, it's fine. So order is for amoxicillin PO 30 mg per kilogram per day administered equally in divided doses every 8 hours. Patient weighs 56 pounds of amoxicillin on hand is supplied amoxicillin on hand is supplied as 125 milligrams per 5 milliliters oral suspension. Round all answers to the nearest tens. So the first part of the question says, how many mg will the patient receive per day? So that's a big clue. Your final answer has to be in mg per day. So if you don't have this unit as your final answer, you know you did something wrong, right? Okay, so how many mg will the patient receive per day? So let's start with you could use dimensional analysis. Yeah, so what we could do is 30 mg. So I have to be careful with 30 mg per kilogram per day. Okay, so what I'm going to do first on question 8, I am technically going to do dimensional analysis. Um, yeah, let's do dimensional analysis. Let's do it all in one step. I think it's best to just do it all in one step. Okay, so we started with the patient does weigh 56 pounds, right? Yeah, the patient weighs 56 pounds and we have to get from milligrams to per day. So 56 lbs. And then we know what we want to get. We know that for 1 kilogram, uh, for 2.2 pounds, that's something you should know. So that get rid of the pounds, but I want mg. So this is then we're going to multiply by that complex fraction, 30 mg. This one, I don't know if you can see this, but 30 mg per kilograms. So that's really strange. So it's 30, let me just write it out, 30 mg per kilogram and then divided by day. What the heck? That is really weird. But here, I'll show you. What you could do is simplify this part and then continue multiplying out. So right here, it looks a little bit off, right? You have what's called a complex fraction. So whenever you're dealing with complex fraction, just simplify it. Don't, um, yeah, that somehow gets rid of the kilograms and then you're left with day. And some people just assume you're just going to get mg per day, right? But you got to, I'll show you how they got this. So when you do multiply this out, you will get your final units will be mg per day. Okay. So somehow the pounds disappears. Well, the pounds disappears, but the kilograms disappears, and then you're left with mg per day. I mean, sometimes you can see it. You can see that the kilograms disappears, and then you're left with mg per day, right? The pounds disappears, the kilograms disappears, and then you're left with the unit mg on the top and day on the bottom. But if you really want to be like if you really want to see it, you can simplify this. So it would be 30 mg per kilogram and then divided by day over 1. Okay. So so yeah, sometimes you can see that the kilograms disappears and then the pounds disappears and you're left with mg. But if you really want to simplify this, you can simplify. So this would be 30 mg, and then this would be kilograms per day. I don't know if this confuses you more, but I'm just going to show it to you. Okay, so when you do this complex fraction, now you're left with 30 mg on the top, and then on the bottom, it's kilograms per day. Okay, because it's a complex fraction. So what I did was I simplified this complex fraction. I did 30 mg per kilogram, and then this long side means divide, and then day over 1. And then remember when you're dividing fractions, you cross multiply. So what's 1 times 30 mg? 30 mg, and then cross multiply what's kilograms per day? That's kilograms per day. Okay, and then over here, you're left with 1 kilogram over 2.2 pounds. And then you're left with 56 lbs over 1. So now you can see that the lbs disappears, the kilograms disappears, and now you're left with mg per day. I don't know if you can see it, but some people can see that this disappears, the pounds disappears. Now you're left with day and mg on the top and day on the bottom. I don't know if you can see it, but if you can't, just simplify the complex fraction and then once I have it to this point, just multiply across 50. What's 56 times 1 times 30? Uh, that is 1680. Wait, and then you're left with mg on the top. And then on the bottom, what's 1 times 2.2 times, this is like invisible 1. Yeah, 1 times 2.2 times 1, it's 2.2. And then on the bottom, you're left with day. Okay, simplify this. What's 1680 divided by 2.2? That is 763.636, and then your unit is mg per day. The directions specifically said, part A says round to the nearest, or it says round all answers to the nearest tenths. So we'll do that. So 6 is the tenths. Look at the neighbor. it's not 5 or beyond, so it's going to be 763.6 mg per day. Okay, you can also write it as a horizontal, I mean slanted. You could say 763.6 mg per day. Okay, so this is an example using a complex fraction. I don't know if that confused you more, but yeah. Okay, let's move on to question B. Question B says, how many mg will the patient receive per dose? So that means it's a big clue that your final answer should be mg per dose. If you don't have it mg per dose, that means I must have done something wrong, right? So mg per dose. I think what you do is take the answer from part A, which is 763 mg per day, and then you divide it by 3. That's it. Because in part of the legend, it did say something about every 8 hours, right? So in one day, there's 24 hours, right? So we're for so okay, so the answer from part A was 763.6 mg per day. But we're doing it, it's distributed in every 8 hours, right? Every 8 hours. But in an out in one day there's 24 hours, so 24 divided by 8, that's 3. So all you got to do the divide this by 3 and so that would be 254.5 mg per dose. There you go. Okay, question C. How many milliliters will the patient receive per day? So that means your final answer shall be milliliters per day. So we can do this using the dimensional analysis. And what you could do is take the answer from part A. What was the answer for part A? It was 763 mg per day. So yes, take the answer from part A, or so the answer from part A was 763.6 mg per day. And we want to get ml per day. So we want to keep that day, just got to get rid of the mg. So you kind of have to use another piece of information from the problem. So they said that in the problem, it amoxicillin is on hand is supplied by 125 mg per 5 milliliters. That was part of the question, right? Um, I'm going to use this to get rid of the mg. Now, should I leave it like this? Should I put 125 mg on the top and 5 milliliters on the bottom? No, because you want to get rid of the mg. So what you're going to do is you're going to flip it. That doesn't change it, right? 125 mg per 5 milliliters is also the same thing as 5 milliliters over 125 mg, right? You can do that. So that's what I'm going to do because that'll get rid of my mg and then 5 milliliters. Now we have the mg disappears, and then you have milliliters on top and day on the bottom. That's perfect because that's what we want. So all you got to do is do the multiplication. So 763.6 times 5 is 3818. And then on the bottom, it's 1 times 125. That's 125. And you get 30.544. And your units are going to be milliliters per day. Okay. And then round it to the nearest tenth. So 5 is the tenth. So it's going to be 30.5 milliliters per day. Okay, last question. So part D, is asking me the final part of the question. How many milliliters will the patient receive per dose? So your final answer shall be milliliters per dose. So what you want to do is take the answer from part C, 30.5 milliliters per day, and then just divide it by 3 because remember it was distributed every the dose is distributed every 8 hours, but in 1 hour in one day there's 24 hours, so 24 divided by 8, that's 3. So all you got to do is take the answer from part C, 30.5 milliliters per day, and then you divide that by 3. So what's 30.5 divided by 3? 10 point 10.1666. And then it's just going to be milliliters per dose. And then it says round we have to round to the nearest tenth, so 1 is the tenth. So it's going to be 10.2 milliliters per dose. Okay, so that wraps up for this video. This was calculating dosage based on body weight. Okay, the next video should be calculating safe dosage for pediatrics.